Cloud-native development presents new challenges for security teams. Ephemeral workloads are scattered across services, and it's hard to identify resources, monitor configurations, and ensure compliance. Prisma Cloud by Palo Alto Networks is a comprehensive cloud-native security platform, delivering full-stack protection for multi- and hybrid cloud environments. It provides deep visibility, threat detection, and data security, as well as protection for hosts, containers, and serverless while enforcing policy guardrails. Visit securityweekly.com/Prisma Cloud to gain control over your cloud security. We discuss application security a lot on this show, and we know that the implications for code security have become even greater as cloud adoption accelerates software development. Shift Left bridges the gap between security teams and developers to find and fix vulnerabilities accurately from the source. Shift Left Core is an innovation in code security with industry-leading accuracy and speed. It combines next-generation static code analysis, intelligent software composition analysis, secrets detection, security insights, and contextual developer security education in one easy-to-use platform. Learn more and create your free account at securityweekly.com/shiftleft. Whether you need to manage bots, protect cloud applications at runtime, stop formjacking attacks, or secure your web applications and APIs, only Imperva offers a unified solution to protect from edge to application and data in one tool. Imperva helps you achieve more, save money, and become more efficient with fewer security vendors needed. Start a free trial today to easily protect your apps and website with Imperva. Learn more at securityweekly.com/Imperva.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella, and this week with Matt Alderman. Do you want to stay in the loop on all things Security Weekly? Visit securityweekly.com/subscribe to subscribe on your favorite podcast catcher or our YouTube channel. Sign up for our mailing list. Join our Discord server and follow us on our newest live streaming platform, Twitch. In our May 27th webcast at 11 a.m. Eastern, we'll explore the latest attacks against DNS and the latest techniques that make it possible to discover and disrupt those attacks. In our June 3rd webcast, also at 11 a.m. Eastern, you will learn about pen testing tools and why every organization should be using them regularly. Register now at securityweekly.com/webcasts. If you miss any of our previously recorded webcasts or technical trainings, they are available for your viewing pleasure at securityweekly.com/on-demand. And this brings us, John and Matt, to our news segment. And wow, do we have a lot of news this week. Let's start with some alliteration. I was talking about trust and trustworthiness, or perhaps untrustiness in Terraform. John, this one was on your radar. Tell us a bit more about potential RCEs here.
Yeah, this sort of popped up over to on my radar somehow, and it as that's a good chunk of what I do in the day job is securing Terraform stuff. That sort of caught my attention. So this is the issue itself is not the interesting part to talk about here, but I'll talk about it briefly. So the issue itself with Terraform, and probably a lot of these type of things. I mean, you can do this. I'm not sure if the other ones have the same type of vulnerability. Let's talk briefly about Terraform, then we'll talk briefly about how this works, and then I'll talk about the interesting part. And I'm going to do this all really quick because we have a ton of stuff to cover. So Terraform, usually you do a Terraform apply with your configuration to go ahead and have Terraform, which is a infrastructure as code open source project from HashiCorp, and it would go and automatically create your EC2 instances or your EKS or maybe your AKS or let's get Google in here too, and some sort of GCP things. That's what it does. There's two ways you can run it, either Terraform apply or Terraform plan. According to their own docs, Terraform plan is a non-operations execution mode, which really sort of compiles, and I'm using compile loosely. It interpolates the script, put the correct variables in, gives you a final version of that, what it looks like, and that's how it goes, right? So that's what's going on here is with Terraform plan, there is the ability to, it turns out that actually does some amount of execution. So it has to download modules if you're using third-party modules in your script, like those things I was just talking about, they're all separate modules. But it has to download those and then do some amount of execution to come up with that final plan for someone to review. Or a lot of the static analysis tools like our Terrascan, we can take Terraform plans as an input and then do the analysis on that. As I just said, both what HashiCorp says what the public generally think. There's no execution there. It turns out there is potential for remote execution when you're downloading those third-party modules. They could be, have some sort of malicious code in them. Where this becomes really interesting to me over the last week is I've talked to different people about this. Obviously, folks in my company, our ears perk up. We're like, got to make sure this doesn't happen. Tell our customers. You go out to the IAC people and people out there, they sort of go, oh, I had no idea you could do RCE. When I talk to this about security folks and drop it into like a security Discord or security Slack, people are like, well, yeah, no, duh. It's like, I think one of the actual lines I heard is just like Python. You don't expect downloading code and running it in Python to be an RCE. So it's very interesting to see how different people think about this type of vulnerability. I think it's partially the security folks didn't fully understand how Terraform works. But I think also it was such a blow off the way the response I saw. It reminded me exactly of this issue we're going on right now, where like the disconnect between security and dev. So I thought that was the most interesting thing about this. And I think it's sort of more of an academic thing. It's probably not going to be, I'm going to regret saying this, but probably going to just be not something we're going to see in the real world. But that's that one. It was a fun read, I think.
So John, I'm curious, why would you use a Terraform pull request versus a Terraform plan? Kind of why would you use one over the other, and therefore creating this potential vulnerability of remote code execution?
Yeah, so Terraform pull is actually for pulling down state. So Terraform is a stateful system, but the thing is, usually if it's being run from a CI process or things like that, the state's not going to stay on that machine because the machine's not going to exist in 5 minutes. So you upload it in Terraform Cloud or S3 or somewhere to actually keep that state, the state of what you actually deployed. So that's what Terraform pull does, versus Terraform plan is just sort of basically making sure, it's sort of linting the code, making sure everything works, give you an idea what you're actually about to go do, because you could be about to incur hundreds or thousands of dollars worth of costs. And that's sort of the difference between those two. What I did leave out, the main place where this is really sort of a nasty gotcha, if you're using something like Atlantis, which is an open source project to do to do GitOps style deployments. So with that in place, you do a pull request on your Terraform code that goes into GitHub, what have you. Atlantis sees it, pulls it down, runs Terraform plan against it automatically on one of your servers, and then puts the results of that into the ticket for someone to then do a comment and say if they like it, I think it's Atlantis apply, and it'll go ahead and automatically run it. So in this case, it means without even a human getting involved, if someone manages to get a module into your code or control one of those modules out there, they now have the ability to run something on your CI system without you having any expectation of what's going on at all.
And so
it's...
Yeah, and where I wanted to tie this, right, is this whole supply chain risk issue that became highlighted under the SolarWinds attack, where you've created potentially this interesting backdoor into your supply chain by running Terraform plan, right?
Mm-hmm.
Yeah.
Yeah. And that's it, but it's at a point where you wouldn't be thinking about supply chain. So this is something I started talking about probably about 6-8 weeks ago, Matt, of my sense is the build systems are probably the least secure part of a development of a engineering team's systems. They're not really looking at how do you secure your Docker builds or the build system that it's on, right? They're sort of thinking about everything before and everything after it. But so yeah, I think this is probably the first of a bunch of these type of things we're going to see.
Yeah, I mean, look, RSA conference started today. This is part of the RSA conference 2021. Supply chain is a big topic in a lot of the early sessions because of what happened with SolarWinds. This is just another area that has to be addressed from a supply chain issue. If we're going to really protect against these supply chain attacks, you have to secure the pipeline. And this is one piece in the pipeline that potentially is vulnerable.
Yeah.
Yep. Yeah, no, great conversation. I think the only thing that I can add here is that I am a believer when talking about the countermeasures in having egress filters, and I'll quickly concede the point that S3 already can be a great exfiltration vector, but if you can at least have your environment locked down so that you have to explicitly approve the destinations for outbound requests, it hopefully can be something that is more obvious that S3 is being the destination here, or you have some better NetFlow for NetFlow logs for your forensics after the fact, of course. But I think what we can do here is we've got an article here about the CNCF and supply chain, and we're building up to that.
We sure are.
Why don't we, Matt, since you're here, give us, speaking of supply chain too, or maybe a bit more of the businesses out there, give us a little bit of insight into what you've been paying attention to the last week or so.
Yeah, I mean, it's interesting, right? The first two articles is where I prompted this, right? Because I'm looking at the new CNCF framework. And okay, we need to verify source code. Well, we've known that for a while. Static analysis, software composition analysis, etc. Right? It all makes sense. But you skip down to number 3 and it talks about protecting the build pipelines, which is exactly this previous conversation, is how many people are actually securing the build pipelines. And so the reason I saw that first article was so interesting to me is because this is a hot topic right now. There's a lot of people talking about supply chain. We've done some micro interviews with some of the different analysts today from Forrester. This is a really, really, really hot topic, and everybody's talking about it. But we don't think about the build pipeline, the CI/CD process, and in securing that. And that is a major component in the supply chain security mechanism. And here we have Terraform Plan creating remote code execution vulnerabilities as part of this pipeline. So I thought it was just a very interesting set of articles here, because this is all the rage right now.
Yeah, absolutely. And the idea with the build environments too is that you have so many different services connecting into it that builds on, this other aspect of mutual authentication, that should these services be connecting into the build environment? And if they are, how are they executing? Are they executing at a privilege level that could actually affect the source code, change the artifact is building, or how could they change the way the artifact is built? Or especially talking about like Terraform plans or Terraform state files, where are credentials showing up? And our credentials hopefully are being, they're not being placed into code or into your infrastructure as code for that matter, but seeing what services have that transitive trust to amongst the access to credentials is always an important thing to make sure that your build system isn't the thing that can actually exfiltrate secrets as well.
Yeah, I mean, this was always a conversation that Paul and I were having as we were porting our software into the cloud and looking at different aspects, like what do you do with credentials, right? Where do you put them to protect them so they're not sitting in your Git repositories, et cetera, et cetera, et cetera. I mean, if we think about the SolarWinds attack and what happened, where they compromised the build systems and was able to inject initially benign code that ended up being malicious code, this is a huge issue, right? And I think it's just very important, and that's why I think we're seeing a lot of articles around this week. It's a super hot topic, where how do I protect my build system so somebody can't infiltrate my build process, inject a piece of malicious code that looks completely legit because it ended up coming out from my build system.
And one final note on that, or one more note, we'll see if it's final. And this is something that I did a few posts on LinkedIn last year. I think I did a blog post about it on, if we look at what comes out from the cloud providers on a CI/CD system. I went through and I think I graded like the top 3 clouds. But they make it look so simple and make it look such a clean, light diagram. They leave all the complex, hairy bits out of it. And, we're seeing a few studies out. I'm working on another talk for a DevSecOps conference. And I just sort of been thinking about this, and like, there's all these stats out showing that like developers and engineering teams, they have a hard time actually understanding what should this CI system be like, how should it be run. And I'm just talking about running it. We haven't got to securing the damn thing yet. Mm-hmm. So, there's also a series of blog posts out there recently talking about DevOps or DevSecOps engineers shouldn't exist. It should be, DevOps, right? Just the developer's problem. But I think that's running a little bit into like a pure Agile or pure Scrum, where no one actually really does that. So it's going to be interesting to figure out how this stuff breaks down. But yeah, we're not there yet.
Yeah.
Not there yet, and that's one of the reasons I pulled up this other article about integrating Rust into Android, and we actually talked about this a couple episodes ago, back in 147, on the security reasons for it. But the reason this particular article came around to my radar again was that it ties into what you were just talking about there, I think, John. The aspect of, it's one thing to say we're going to use this language for security reasons, or we want to we want to have better memory safety. It's another to actually have the build environment and that basically what we're talking about right now, that CI/CD environment for the language of choice. And this article from this blog post from Google was pretty interesting just on that aspect of, here are the steps necessary to make it possible for developers to adopt this language, even if we've said from a security perspective we want to start using it. So I think it kind of ties into that theme with you. I was going to switch on to talk about some HTML aspects. One, I was looking at Webhooks security that talks a little bit about secrets and request signing, but also Matt, you were looking at this new API for HTML sanitization as well.
Yeah, I thought this was interesting, and it goes back a little bit to the previous conversation a little bit around how to protect the browser. And Google, Mozilla, and Cure53, they're collaborating on creating an API for HTML sanitization. I thought that was interesting. Didn't bring it up on the last segment, but it's like, is this a way to help us have better HTML to prevent things like cross-site scripting and other things? And so what you're seeing is the browsers taking a more active role in trying to do some things to actually help protect, some of this code running in the browser, maybe preventing some of these attack surfaces that we've talked about for a long time, right? We know certain OWASP top 10 have kind of fallen off the list, but cross-site scripting still out there. Is this another innovation to help us, really protect the browsers and the application? So I thought it was a very interesting article that popped up today.
Yeah, I thought a good time in the spirit of CSP, the idea that it doesn't fix cross-site scripting, it makes basically the exploitation of cross-site scripting more difficult. And one of the things that just stands out for me on this one is that HTML for the longest time has had so many quirks. It's either this for IE, this for Firefox, Safari, etc. That HTML5 and just HTML working group, or the what working group right now, is making that a lot standardized, which is far, far better. And the point here is to say, if we're going to sanitize and try to figure out what a tag and what a DOM property should or shouldn't have, let's at least do it in a standardized way so that it doesn't work on browser A, but then can be trivially bypassed on browser B just because of an implementation difference. So, hopefully, a good idea there.
Yeah, hopefully this fixes at least the cross-browser compatibility from Chrome and Firefox in this particular case. Unfortunately, Microsoft's not part of this group, so I don't know what it's going to do for Edge, but at least two of those main browsers have some standardization across them.
At the very least. So I think we're starting to step a little bit away from supply chain. But Matt, you had some other articles about some
product announcements.
White hat and product announcements.
Yeah, there's just some, one of the things I was doing in prep for Enterprise Security Weekly this week is really monitoring the news of what's coming out of RSA conference, right? And we know that today's like the big news day for most organizations. Maybe not as big as it's been in the past because we're virtual versus physical. But as I was going through the news, I was like, there's a couple very interesting product announcements on the application security side. So this one is White Hat Security is doing an integration with Bit Discovery. And we just did an attack surface monitoring review out of labs. Adrian and Paul did that review, and Bit Discovery was in there. And what I thought was interesting about this is the integration of Bit Discovery going out and doing these attack surface kind of reviews, and then integrating that with some of the vulnerability stuff on the White Hat side to say, hey, can we come up with a better way to really identify what some of the real vulnerabilities are in the attack surface from a web app perspective? And so I thought this was a very interesting announcement.
Yeah, I think for me, just to add to that idea of attack surface, we often go back to that very simple premise of, do you have an asset inventory for your network? Do you have an application inventory? And do you have an asset inventory for what's been deployed into production systems? And even in the last segment, we were kind of getting to that aspect in terms of what's all the third-party JavaScript, what are the third-party resources that you're loading into your own app. So definitely a common theme there that's, as always, easy to say but difficult to execute in progress, in the sense of answering that question, what is my attack surface and how much confidence do I have that my attack surface has been enumerated correctly?
Yeah.
It got to feel to me like we're starting to see things moving towards threat intel on the development side, which is, it sounds interesting to me right now. I think for a few years, the threat intel was just another, moniker for a Band-Aid, and didn't really have the best opinion from me about it. But I think the idea of, as we talk about supply chain, all these different types of things, the idea of putting threat intel in there in that mix, that has interesting aspects to it. So be interesting to watch.
And especially when I think we can start to correlate known threats against my existing assets that are publicly accessible on the web, helps us start to get some context around where the real risks are from an application perspective. And I think that's the interesting part for me, right? Because we've thought about threat intel in certain scenarios, but maybe not at the full layer 7 application layer. And we're starting to see some movement now to say, look, these are things we're seeing. This is your environment. I'm correlating them with known vulnerabilities on the app side that can create attack vectors that we need to address. And if we can use that data, John, to actually help prioritize application security vulnerabilities, we start to get better insight for the security teams to prioritize what we need to fix in our apps and what we maybe don't have to fix in our apps.
Yep. I was scribbling a note. It was originally started off in my head as a joke, but the more I think about it, I think it might actually start happening. Does that mean we're going to need SIM for engineering? And I think in a way,
maybe, right?
I could see one of the big companies coming up with that.
Yeah, so think about this for a second, right? If we can integrate application security threat intelligence in and correlate it with other things that are going on, can the SIMs be the platform for aspects of this? Maybe. I think the challenge with the SIM, just in general, is it's more of a security operations function. I'm not sure it's ready to be leveraged by a DevOps team from a DevSecOps perspective yet, but I could see where those markets start to come a little closer together.
Yep, that's why I was saying I could see one of the large companies doing that might have a focus on developer first. That I could see happening in the future.
So as you all are turning on your threat intel detections and insights, I want to throw up an interesting angle from for your threat models. And this fintech startup offers $500 for payroll passwords. So in addition to having a nice alliterative ending right there, it's a kind of different threat model that we don't often think of, in the sense of, here is credentialed access, which, as always, credentialed access is the best backdoor out there for attackers and malicious actors. But in this case, this is essentially, a sort of B2B setup where a third party doesn't have access to an org's API, or that org doesn't offer an API to expose data. So they're just going in through essentially shared credential access. So I thought this was pretty interesting from the sense of we've seen related aspects of this in the sense of just scraping attacks. For example, LinkedIn this past year, there was a big court proceeding around that and the legality around screen scraping. And now this is essentially authenticated screen scraping. And so I thought this was a very interesting type of scenario to add to threat modeling for product security teams, as well as thinking how well do we, or as well as reinforcing the idea of what can we do better in terms of enforcing multi-factor authentication, or things that just are going to make this type of shared credential either more detectable or just more difficult for even if it is an ostensibly approved at least by the user, implicitly so, type of activity.
No comment on that one. I mean, I could, but I'm not sure that I want to.
The comment I was going to make is, I think the reason this one got attention is because it's a $500 payout, right? Mm-hmm. I think there's a lot of companies out there that do this exact same thing, but they're not paying the customer. I mean, how many products want like access to your, your contact list, and so they just went a little far. Yeah,
it went a little far, and it's a little scary that there's companies out there paying for that information to use it. And not only are they paying you $500, they're paying you $500 plus a fee every month that those credentials stay legit. Which it's a recurring revenue model, which I'm not sure that's what we really want to encourage here.
No, and I think too, and that's why I couldn't find the link to the research, but I think that the number was something like people were paid $13 or would give up their password for something small. In this case, at least the value of passwords has gone up. But I will say that I don't think it's actually the value of the password here. It's the value of the data behind that. Yeah. And so it becomes very interesting from application owners to think about how defensive can you be and should you be, or could you be, to use all the different qualifiers in there, of your own users as well as their data, and not only just from hacking, exposure on things like GDPR risks, CCPA risks, those types of things, but also there is a business intelligence aspect here too, in protecting your IP. So it's a pretty interesting area to explore into that, for me at least, had a good business aspect to the threat model rather than just pure technical ones.
Yeah, I mean, my only other comment on this is I'm surprised Facebook didn't come up with this first and just figured it out so they could just get more data into Facebook. I'm just saying.
Well, and I make the point on the write-up too. It's like part of this is actually solved. This is one of the premises of what OAuth is kind of designed to do. So you don't have to share your credentials. You just are granting, you're authorizing access to a third-party service to get to your contacts, like John mentioned, or to some other feature, or to tweet on your behalf, those types of things. So this is an area that does have some solved problems, so to speak, but that is predicated on the idea that the application owner wants to grant that authorization via APIs, via this type of OAuth setup, versus having a third party come in straight through credentials. So fun ways of trying to figure out authentic versus inauthentic behavior. So good discussions, some good pre-mortems, if you will, for your application, your DevOps teams. I do want to get to one. I want to touch on Wi-Fi frag attacks real quick, just because I wanted to highlight that as a neat non-web type of attack that was just another example of a researcher poking at some ancient, in internet terms, Wi-Fi standards, finding some cool flaws in the way fragmented packets are handled. It's not the end of the world for Wi-Fi networks, but it does have it has a good explanation of what the consequences are, whether you can target the client side or the server side of the communication. But once again, just a neat write-up. We love highlighting good write-ups, good technical write-ups that are clearly presented. So wanted to throw that one out there. Not sure if Matt or John, you had a chance to look at this one in a particular detail. But we can talk about that, or get to the one other article at the very least that I wanted to make sure we did talk about, because I think it's going to be fun.
I leave Wi-Fi to Paul and Larry because they're the experts. So no comment.
Sounds good. So here's where I think we might get some more comment out of you, though, Matt, is great article from Phil Venable. So a well-known person within the history of information security, and I think currently the CISO at Google Cloud. And the title of the article is complexity the enemy of security? And it's Can
I answer that rhetorical question first? Because
you're going to beat me to it. Go
yes
for it.
And no.
So that's what I liked about this article, is that it switches the framing on us. It says, maybe that's not even the right question. Maybe we should actually be talking about bad design instead. And what was neat to me about this article is that, yes, we can easily do that yes and no in terms of complexity, but what this article did was say, let's actually show some examples of when we say complexity, we might just be talking about bad design. Either design in our user interface, so that user experience could be a bad design in the process. So why are we blaming people when the process actually failed people? As well as doing things like that blame-free or blameless post-mortem that we've talked about before. There's a lot of really, I think, good aspects to this article that really stood out to me as a way to approach thinking about security.
Yeah, the first thing when I saw the title is I was thinking about Dovi Daizovi's keynote at Black Hat, like, I don't know, 2016, 2017, where he was talking about how the modern application in a microservices architecture could actually, that complexity could also help us from a security perspective, right? Because if I have a lot of moving components that are changing often, it doesn't give the attacker a static application to continue to attack. And part of that complexity also creates high friction and high cost for the attacker. And so my first thought in the process was, well, yeah, complexity could actually help potentially in security if done right. And I think what Phil did in this, and he was formerly at Goldman Sachs, and I spent a lot of time talking to Phil and the team when I was at the RSA on the Archer side about stuff, because Goldman was doing all kinds of super advanced stuff. I mean, they would just literally build it themselves. And because they knew exactly what they wanted to build, they weren't necessarily taking commercial off-the-shelf products because it was too expensive for them in some respects to kind of make it work in their environment. So they were very on the leading edge of innovation in the space. And when I got down into the article, I'm like, yes, it is about design. See, complexity can give you advantages because, like I said, if components are changing frequently, I'm pushing code 7 times a day or once a day or whatever, it keeps the attackers on their feet. They constantly have to relearn aspects of the application. The complexity could create kind of a layer of security just because the services are constantly changing. But he gets into the point where, but it's about the design. See, if the design's wrong, then complexity could actually hose you. And we were just talking about this on the last segment a little bit, right? Pushing stuff to the browser, into the client to do processing was we did it on purpose, right? I mean, we really thought about how could we make our applications perform better by doing more at the client. That added kind of the fourth tier to the application security space. But if we're not protecting all those layers appropriately, then this complexity also creates some very interesting security challenges.
Absolutely. And that's why for me, leading off with just that idea of abstraction and what does your abstraction layer look like makes a lot of sense. Because as you said, there can be a lot of complexity in infrastructure as code, the way that you're managing secrets, rotating secrets. So you can have really complex IAM policies. You could have functions as a service where individual functions have read-only access or write-only access. And yes, it can sound very complex, but when you can abstract that into for mature teams, into essentially some infrastructure as code to get that interrelation set up well and correctly and least privilege access, that I strongly agree that can work to your benefit as well as if you can build into that from the security perspective, build in those opinionated defaults and those configurations that say, this is the paved road, to use the other one of the, hopefully it hasn't become quite a cliche yet, but the other common tenets of DevOps and how to build networks that are complex but can still be extremely secure.
Yeah, and then we go to declarative configuration, which was part of the conversation on the last segment, which is, look, now if I can apply configuration around these individual abstracted components, but also dynamically update the policy to enforce that configuration, now I get some very interesting aspects of security in this very abstracted layer. The challenge is, how do I build those configurations and those policies to make sure that they stay where I set them and they're not being changed by the marketing team or the development team or whatever. And so policies have a great place, but having spent a lot of time in the policy side, policies have to be dynamic. They cannot be static anymore. And declarative configurations are a way, if I can do some automation around it from a policy perspective, to really enforce that around these different components in a complex system. And abstraction with really coupled with this concept create some very interesting security aspects.
No, I agree. There's one other aspect I do want to touch on in this one, but I want to make sure that we give John. Anything about this particular article that stood out to you that you wanted to add to this?
No, it's a good read. It's and it's whereas we talk a lot of even like the one you had previously, a lot of sort of technical write-throughs. This is a real good think piece. He actually wasn't on my radar, I'm embarrassed to say. So I've got some reading ahead of me to sort of go through and think a lot of things he's been writing about. But I think you guys have covered it pretty well. We don't need to beat that horse anymore.
Perfect. But we've managed to give John Kinsella more reading homework. So once again, for those of you keeping your bingo cards full, hopefully this is another successful week. And I will say, just as my final comment on the article, I did like the number 13, lucky 13 here. But the idea that human error is not an explanation, but rather something to be explained, this very much speaks to me in the idea of, why are we stop blaming the user, stop saying the user is stupid, the devs are stupid, or even necessarily devs don't care about security. Maybe they don't care to deal with the onerous process that you've put around for security. Maybe they just are an expert on Go and Ruby, but they're not an expert on network design, but you've handed them an AWS environment where now they actually have to figure out how to hook these things together. So it's these types of questions, these types of ways of poking around and figuring out what you're collaborating with and where you can collaborate with, I think is a better way to put it, with your developers, I think is a great way to run with that. So read through the article and think about it. It's a good one for me, at the very least.
Very good.
And I think with that, we're going to have to say thank you. Thank you, of course, to John. And he may not be as thankful for the reading assignments, but always good to have you here, John. And, of course, great to have you back with us this week, Matt. And I want to thank everybody who's with us live in the Discord as we're live streaming this, and everyone who listens to us on all of the different podcasts that you have out there. Thank you for joining us. We'll see you again next week on Application Security Weekly.